Today we will see the conversion from hex to decimal. Now what is this conversion from hex to decimal? Hex number is the last type of number in the number system. Now when we say hex, hex means 6 and hexadecimal means there are 9 digits from 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9, and the rest 6 digits, like after 9 comes 10, they are actually 2-digit numbers, so they are represented by a single symbol, that is capital A, B, C, D, E and F. So hence the number is hexadecimal number. Now this hexadecimal number is user friendly, so it is used in mathematics, information technology. But one thing you will remember in this, it is also called as a 4-bit binary equivalent number. So which means that each hex digit is represented by 4-bit binary digits. Now let us first see the conversion from hex to decimal. So when we convert hex to decimal, generally what we do when we convert from binary to decimal or octal to decimal, we multiply the each digit by its equivalent power, starting from rightmost bit to the leftmost bit, and then sum up this multiplied value and get the equivalent decimal output. So in hexadecimal, in this hex to decimal conversion, what we do, we consider the digit from right to left, and each digit will multiply by its base. What is the base? Base is 16. So then the first digit LSB, that is least significant digit, will be multiplied first by lowest power of the base, that is 16 raised to 0, then add up by multiplying the second digit by 16 raised to 1 and so on, and add the multiplied value and get the equivalent decimal number. So now in example, we can see we have shown a hexadecimal number 3b with base 16, right? So what we'll do now, what is our least significant digit here? B. But what is B? B we know is equivalent decimal 11. So 11 will multiply by lowest base of the number, that is 11 multiplied by 16 raised to 0, plus the next number is 3 into 16 raised to 1, and then this is only the 2 digits, so we'll multiply only by 16 raised to 1. So then that is equal to 59. The sum up is equals to 59 to the base 10. This is how you convert a integer hex number into decimal. Now what if we have fractional part? So in fractional part, the only difference is that after decimal point, whatever digit we have, we multiply by negative power of the base. So now we have a number given here 0.8. So point is actually 0, the decimal point what we get. So we'll multiply 0 into 10 raised to 0 into 16 raised to 0. That is, we move when it is a fractional part. We have seen already in other conversions that we don't move from right to left, we move from left to right. That is, we consider first the most significant digit, then the least significant digit. So now our first after decimal point, what is the number we have is 8. So 8 multiplied by 16 raised to minus 1. So that is 8 multiplied by 1 by 16. So 8 2s are 16. So 1 by 2 is equal to how much? 0.5. So what is the equivalent decimal number of the given fractional hex number? That is 0.5. Now the next conversion is from decimal to hex. So decimal to binary also we saw. Why I am giving the reference of binary always? Because that is the first very important type of conversion we see and we continuously use. Now the decimal number given is what here is 2250. What we do? We go on multiplying the given decimal number by 16, that is base is 16, and continue the division till our quotient becomes equal to 0. Then what is our answer? Answer means the result, that is what is our hex value. It is nothing but we saw the remainder. The first remainder represents the least significant digit, which is the rightmost digit, and the last remainder which we obtained is the most significant digit which we get in the hex representation. So divide 2250 by 16, we get the quotient as 140 and we get the remainder as 10, which is equal to A. Then again divide 140 by 16, what do we get? The remainder as 12. Then write down the remainder, then divide 140 by 16, what do we get? The remainder as 8. So then how many remainders we got? 1, 2 and 3. But how to represent? From bottom to top. So that is 8CA. So most significant digit to least significant digit, we get the output as 8CA for the equivalent number 2250 decimal. So this is how you convert an integer decimal number into hex number. Suppose it is a fractional decimal number. What we do? After decimal point, whatever is the fractional number, we carry out repeated multiplication. So go on multiplying, and whatever integer part we get, that is the used for representation of the equivalent hex value, and the fractional part is the multiplicand or the next multiplicand. Until when you go on continuing this multiplication till the fractional part becomes equal to 0. But there is one difference in the representation. We don't represent from bottom to top, we represent from top to bottom in case of fractional number. So this you have to remember, which we have seen earlier also. So this is how conversion from decimal to hex. Now the next type of important conversion is hex to binary conversion. Now hex to binary conversion. What we do in hex to binary conversion, as we have seen decimal to binary conversion, again binary number is nothing but what? It is a strings of 1 and 0. That is, it has the positional weight of 2 raised to 0, 2 raised to 1, 2 raised to 2 and 2 raised to n, so on. Now when we want to represent a hex number, as I already introduced at the start, we represent a hex number by 4-bit binary number. So this 4-bit binary number represents one hex value. So then for example, there is one hex number, that is 4FA, which base is 16. You have to represent its equivalent binary. So first what we do? We separate each digit in the hex number. Then after separating each digit, we write the equivalent 4-bit number of that particular digit or particular symbol of the hex number. So now here first number, the least significant digit is A. A is equal to what actually? Decimal 10. So what is the binary equivalent? 4-bit binary equivalent of decimal 10? 1010. The next number is F. What is the equivalent of F? 1111. The 4-bit equivalent of F. F is what? Decimal 15. What is the next number? That is 4. 4 is equivalent to 0100. So then this way we have represented the 4-bit equivalent of each hex number, group them together, and that is our equivalent binary output of the given hex number. This is for an integer number. Suppose there is a fractional part. So how do we represent? If there is a fractional number after decimal point, whatever fractional number we will have, we will not read it. How we will represent them? We will not read it from right to left, we will start reading after decimal point from left to right and make a group of 4-bit and represent the equivalent binary. Clear? Now suppose we have to convert now reverse, that is convert binary to hex. What we'll do in this binary to hex, as we have seen in other number system, binary to decimal, or we have seen binary to octal. Basically binary to octal, we group them. So here also in binary to hex, so we saw that each hex number is what? Representation of 4-bit binary. So what we'll do here then, we will represent each binary number, we'll take into consideration, group them into 4-bit, starting from the LSB bit going towards the MSB bit. We will go on grouping them into 4-bit, and each 4-bit will represent its hex equivalent. Now one example, not the solution, but see the example only. Take the bits which is represented in the written in the example. So now start reading from the LSB bit, that is 1 0 0 0. It is a group of 4-bit. Next number is 0 0 1 1, next 4-bit. But the last group 0 1 means we are falling short of, it should be a 4-bit binary number, we are falling short of 2-bit. So what to do in this case? When we group from right to left, we add more 2 zeros to it. Don't discard it, as I told you in the binary to octal conversion. Don't discard, we have to add the extra number of bit to complete the group. So now we'll add 2 bits. So then now what will be the equivalent value? 1 0 0 0 will be 1, and 0 0 1 is actually 12, that is equal to C, and 0 1 0 0 is equal to 2. So then what is our equivalent hex number of the given binary? It is 2C1. This is for an integer number. Suppose we have a fractional binary number. So again, what is the method? After the decimal point, we will group them into 4-bit again to get the equivalent fractional hex number. But how to read? Not from LSB to MSB, but from MSB to LSB, that is from left to right. So this is how you convert a given hex number into binary, or you convert a binary to hex. Only thing you have to remember is that you have to practice more examples.